But what I want to talk about today is this idea of combinations. We've been looking at this idea of arrangements. Right? And we know that combinations are a specific type of arrangements, right? Can you write this down for me? A combination, right, we're talking about selecting things. And it's a selection where I might have these examples, right? Maybe I'm picking a hand of cards. Or maybe I'm creating a team for sports. What did I say was different about a combination compared to a permutation? The order, right? If we think about the order of selection, okay? If I pick up these two cards here, it doesn't matter what order I pick them up in, they're effectively the same arrangement. They're the same combination. Same with the sports team, right? It doesn't matter if I pick someone last, 1, 2, 3, I've got all of them in there, that's my team, okay? It's just a selection where order doesn't matter. A selection where order doesn't matter. And remember, the way I said that, I remember that as I see C, okay? I know it's a combination, I'm thinking of a committee, right? So like a committee is like a group, and it doesn't matter what order you pick them in, that's just one arrangement. So if I change the order I pick them in, still the same arrangement, so I have to kind of treat them as one, right? Let's look at a very simple example. Let's start off with a small number of people, A, B, C, and D. There's 4 people there. How many ways can I have groups of these sizes here? Size 4. Now remember, now I'm not arranging them in a line, I'm selecting a group of people here, right? So this one, just have a think about what this is actually asking. I have the people A, B, C, and D. How many ways can I make a group of size 4? It's only one way, right? Because there's 4 people, all right? There's my group. It doesn't matter what order I pick them in, okay? There's actually only one way that this can happen. Think about these ones now. How many ways can these happen? I'll let you try those yourselves. For these smaller examples, it's very possible just to write out what are the different groups we can create. How many ways can we create groups of size 3? What are the different ones I can have? I can have, what, A, B, C, A, B, D. What else can I have? B, C, D. Yep. A, C, D. Is that it? Only 4 ways. Okay. We happy with that? Okay. 4 ways. Groups of size 2. What would that be? Shout them out for me.
AB.
Yep.
CD.
Yep.
BC. AD. And then AC. DB.
No duplicates there? Right? Okay, so 6 ways for that one. And this is the trickiest one. Groups of size 1, well, all that's really asking is, hang on, I'm just selecting one of them at a time. There's only 4 ways that can happen, right? I've got A, B, C, and D. There's 4 ways I can do that. Now, what I always want to do is when I start talking about these new ideas of permutations and combinations, I want you to think back to what I've already taught you about this, okay? When I think about a permutation, it's a selection where the order matters. And remember, we had a notation that helps us recognize what that is, right? If I was saying I had 4 things to pick from, and I'm picking 4 of them, that could be 4P4. If I had something like this, if I'm picking 3 of them, what did I change? I don't have 4P4 anymore, I had 4P3. I'm picking 3 things, right? 4P3. Same here, 4P2, 4P1, right? That was using a permutation where the order matters. The problem here is that then you're kind of like doubling up because I don't want to consider those duplicates. I want to consider all the cases where those arrangements of people, okay, I just have these people. A, B, C, that's the same as CBA and things like that. So I want you to think about what factor am I overcounting by? How can I get rid of those duplicates? What do I need to do with those? Interestingly, 4P1, if you put that in, because you're only making a selection of 1, right? That actually does give you an answer of 4. So that's sort of okay here, right? But 4P, let's think about this one here, right? if I want to remove the cases where they're doubled up, like for example, BA, DC, CB, I don't know, and you can keep swapping them around, right? What factor am I overcounting by? Because I can swap all of these around, but effectively I'm treating them as the same arrangement. So what factor am I overcounting by over here? I have double the amount here, right? I'm overcounting by the amount of people I'm selecting, I know. Because I can rearrange them in some way, but they're actually the same arrangement. So I'm overcounting by a factor of 2 factorial, right? How many am I overcounting this guy by? How many people am I picking here? 3 factorial, right? How many am I overcounting this by? 4 factorial. If you put that in your calculator, get your calculator out for me. If you put in your calculator 4p1, so yeah, this one here, I mean, we could say you're overcounting by 1 factorial, but you know, that's just 1 anyway, so that doesn't really matter. Let's go to the first one. Oh, Eva, you flick the lights off for me now. So if I have 4p4, and I divide that by 4 factorial, right? Yep, there's one way. 4p3 divided by 3 factorial. 4 ways. 4p2 divided by 2 factorial. And 6 ways, right? Okay, so this is the idea of what a combination is. We're taking a permutation almost, but we're taking it in a way where we need to kind of remove those overcounting that we've done. And that's actually one definition of how we can think about what a combination actually is, right? And because mathematicians are very creative, on your calculator you do actually have this button. Instead of working with P, you're working with C here. So there is actually a button that represents this, and I'll show you that in a second. But here's our definition of a combination. If I have n total things, and I'm choosing R of them, okay, yeah, you see here. There's another way we can write this. There's just some other notation as well. I can put that into brackets like this. Yeah? It is next to it. If you go to your calculator, and you look at the divide symbol, you see there's a C there as well. Right? So I've got, in this case, let's try one of them out. So if I have 4 and I'm choosing 3 of them for C3, that does give me 4 over there. Okay, can you guys see that? Right? And you can try that for all the other ones there. 4C3, that'll be 4. All of them work in that same way. What does this actually equal to though, right? I said that this is the same as NPR, all divided by, what am I actually dividing by here? R factorial, right. Now, we can actually derive what the expression of this is going to be. Because remember, think back to what NPR was, right? Because factorial goes all the way down to 1. But NPR had a specific definition. That was this. N factorial just over n minus R factorial. Okay? So we've got a few fractions on fractions here. Okay? But this is actually going to be quite nice. Maybe I'll write it like this out to make it a bit clearer. I'm dividing by R factorial, but when we divide things, what do we usually do? We flip them and change that to a multiply. And this is my definition of what NCR actually is. Can you write this down for me? N factorial over R factorial multiplied by n minus R factorial, which is essentially saying this, right? Here's your permutation definition. I'm taking a permutation, but I'm dividing by R factorial, the number of spots I have factorial, so I'm not overcounting that one there. Does that kind of make sense? So there's just a bit of an understanding of where we get this expression from. NCR is something that we can just put into our calculator. But I want us to do more than that. I want us to understand, like, this is the expression that we need, and there'll be times when we need to use that, okay?